Hi, everyone. I'm Scott Bichuk, partner at Norwest. Thanks so much for joining us today. At Norwest, my focus is on enterprise software investments, specifically agentic systems, aiming to achieve deeper reasoning. For those less familiar with Norwest, we are a global venture firm and growth equity investment firm that's been around for 64 years, and we're currently investing out of a $3 billion fund. We spend a lot of time with founders who are pushing the boundaries of what agents can do. One theme that keeps coming up, the concept that agents can only be as good as the environment they train in. This has paved the way for reinforcement learning gyms. These gyms are places for agents to train, experiment, and make mistakes safely before touching real workflows in production. And they're becoming an essential foundation, but will ultimately be real world autonomy. Today, we're going to go deep into why RL gyms have become a hot topic. We've got an incredible group of experts with us. Ali Ansari, CEO of Micro One, Barak Turovsky, AI strategist, Rohit Patel, director at Meta's Superintelligence Labs, and Forbes' own Anna Tong. With that, let's jump in. Anna, I'll hand it over to you.
Hi, everyone. I'm excited to be here today. Thank you for joining this panel during the holiday rush. I wanted to start with just for a basic question for people like myself. Can the panelists please help us define what a reinforcement learning or RL gym is, and maybe also explain, where in the model creation pipeline are RL gyms normally used? Who
Yeah,
wants
happy
to
to take a first stab at this.
Thanks.
So to think about RL environments is there's a reward model which a policy model is using to train on. So there is tasks that are defined that are functions that some policy model needs to get good at. So you can think of those functions as model capability improvements in any given domain. So we can choose a domain like, let's say, tax, just to kind of convey a real world example. Let's say we're trying to improve model capabilities on W-2 California taxes. The way that we would do so is we would define the action space and state space of what it means to do W-2 California taxes. And we would define with a tax expert, we would define um, tasks that the model needs to get good at. And each of those tasks could be, the tax expert needs to collect data from a consumer to file their taxes, such as their income statement and other information. And then the tax expert needs to have a conversation with the consumer to actually optimize for their taxes. And then ultimately, the tax expert needs to file the taxes, which is a PDF. So what we aim to do with RL environments is essentially train policy models, which are the foundational models, the LLMs, to do these tasks that experts do in the real life that require these like sequential actions through model training. So that's sort of a one example that I would use to kind of convey the
And
RL
great.
environments.
And Ali, I know you're on Micro One, where you're doing a lot of RL, where you're providing RL environments. Do you want to say anything else about your company and what you do?
Yeah, absolutely. Yeah, I'm Ali, founder and CEO of Micro One. We're basically what we do is we're building an AI platform for human intelligence. So the main thing that we do is we vet highly skilled people, mainly PhDs, professors, as well as industry experts, and we help train frontier LLMs. So we do so in the format of providing, frontier data to labs in the contextual and frontier evals, and then we also create RL environments to train these models.
Great. Any other panelists want to share any basics of RL gyms for the group?
Yeah, I can chime in. This is Barak. I'm working currently doing AI strategy and consulting. Previously was a chief officer of GM and also worked on very early, way before they became hottest thing on earth, LLMs at Google, at launch first LLMs at Google AI with Google Translate. So to me, the most important thing I believe is that it's a transition to not generating a nice response, but actually focusing on acting. So Ali mentioned tasks. I think the key is actionable tasks, right? I believe one of the reasons we are now having a lot of discussion and attention on RLG more in general on RL is that we squeezed a lot of value from those large static LLMs and what I would call prompt soup. I generally like kitchen analogies. I'll expand on that later. But I think if you want system to actually act like agents, workflows, especially in physical world, you want to make actions, you really need to measure success and optimize towards the reward, not generate a nice response. So as long as you care about that, let's call it long horizon acting behavior, and also behaviors that will be safe, and there is also cost and quality trade-off at scale, then reinforcement learning, and by extension reinforcement learning, James, becomes a natural next layer.
Wonderful. And you had touched on this a little bit already, but maybe you can go into it a little more. Like, why are RL gyms having a moment right now?
Yeah, I think the main reason is actually very similar to what Barak just said, which is we're going from this idea of answering very complex questions, of course, in domains that are complex, such as medical, finance, legal, and so forth, which models are, getting quite good at that, to actually doing things. So the way to think about models doing things is they're sort of answering multiple questions in a row and then kind of acting on those answers that they've answered for themselves. And if you take, for example, currently, let's assume that models can answer questions with, 90% accuracy on average across domains, just a kind of let's make up an arbitrary number here. And now if you assume that the model has to answer, 5 to 10 questions in a row and then act on those answers, and again, you assume that there's 90% accuracy on each of those answers and actions, and you take 0.9 to the power of 5 or 10, you're very quickly compounding errors, and you'll come up with quite a bad result at the end. So what this means is that acting and essentially answering multiple questions in a row versus one very complex question is a very different thing. And now we're in this moment of this year was supposed to be the year of agents. I think next year will be the year of agents, and the year of agents means we need to get the models to actually do things, and that's the sort of transition that's happening now.
Thank you. Great. Okay, so I have a question for Rohit now. So most RL gym vendors today seem to primarily sell their environments to just a handful of frontier AI labs, and these are folks that are making the really cutting edge models, and they are using them to post-train their frontier models. So, from your vantage point, how have you seen this vendor landscape of startups evolve over the past couple of months? And also, if you don't mind, just give us a little brief background on your on what you do and your background.
Yeah, thanks. Yeah, so I'm Rohit. I work at MSL at Meta, mostly on we've been working on various different models we have trained. I spend a lot of time in eval space and RL, and so why like from a very technical standpoint, if you look at it, like what RL allows us to do is, once you run out of supervised fine-tuning data to update model parameters, and you still want to sort of continue to make model better, you're like, how do I update parameters that are going to be consistent with the world, right? And the simple way of doing it is like have the model do something in the real world, and then reinforce the parameters, that gave it the correct result, right? Like, so that's kind of very simply what is happening at the very core of it. And so if you look at early RLHF work, that was trying to do this by having humans look at responses and go like, hey, this one is better, this one than this one. And so we'll reinforce these answers, and therefore we'll continue to make the model answers better and better and better. And what is happening now is sort of like people are starting to realize, okay, we can move beyond having humans label which answers are better to actually, with high fidelity, match the answers to some state of the world. And maybe these are not just Q&A format anymore. Maybe these are, models are actually taking action and things like that. But you match it with the state of the world, and then you try to move the parameters in the direction that they are correct. So if you look at what the vendors are doing, they're sort of following like what is happening there. Like initially, most of the vendor work was around either creating these supervised fine-tuning data sets for Q&A pairs or labeling them, which one is better, and so on and so forth. And they are increasingly moving into richer and more automated ways of providing feedback to the model. So either by themselves automating this sort of feedback, or by creating a code execution environment like a Docker, or simulating an entire backend, or maybe a job task. So I think that's where this is going, where the models can get feedback from these environments that these vendors are building. So it's an evolution from just data labeling, tagging, to building these things, which we're seeing, which is, I think, like what is needed, and that's a good direction.
Are you seeing an explosion of the number of startups that provide this type of service? And do you have any idea how many there are?
I don't know like what constitutes an explosion, but I am definitely seeing more choices in front of like us. Like when I go out and I would want to do some work on RL or something like that, I would say I have more options now than I had like a year ago. Yeah.
Great. And Ali, so I know you are on the vendor side, so you're a vendor to these frontier AI labs. And I'm sure I've never built an RL gym. I'm sure it's difficult. What can you tell us a little bit more about that process? What's the hardest part of building an RL gym? Is it the design? Is it working with the labs to figure out what tasks should be rewarded unpredictably of agent behavior? What's the hard part?
Yeah, I think the hardest part is the quality of data that goes into these RL environments. Of course, I'm biased when I say this, but I would say almost entirely in RL environments is just human data. Of course, there's you can kind of expand on that data with synthetic data, and there are other parts such as defining the state space, how you're going to design the algorithm for the reward model and so forth. But we sort of think of it as the most important ingredient and frankly the most expensive part to create an environment is the human data that goes into it, and therefore that's kind of our emphasis and the most difficult part as well. And I think I would say there's two things that result in really high quality tasks, sort of prompts and verifiers in most cases. And the first is the expert quality. So basically being able to source and deeply vet the experts that are working on these tasks, and not just vetting them for their skill sets, but actually vetting them for the skill sets that the job and the environment actually requires. And then I would say the second thing, which I think is a bit, I would say, undermined in this space, is the happiness of the experts that are working on these tasks and that are creating the data. Anna, you and I have talked about this a good amount, which we essentially track this notion of expert happiness index at Micro One, because we want to kind of make sure that the folks that are working in the space are having a good time, and this like new job sector that's being created is a fun job sector that is results in good pay. And I think the ultimate outcome of that goes back to quality as well. When experts are happy, they create better data, which therefore results in better models. So yeah, I'll say data is the hardest part, and those are kind of some things that we do to improve data quality.
Great. Yeah, let's talk about talent a little more. So, you know, I'd love to hear about the differences and similarities between talent required to make these RL gyms versus human talent required for previous types of model training. Is there a difference, or is it just more of the same like requirement for human experts?
Yeah, I think similar to what Rohit was saying a second ago, we've went from this idea of like very low fidelity kind of generalist labeling and preference labeling and other types, to very much high fidelity, very complex level data sets. And I think this kind of phrase of like labeling is no longer really the right phrase because of how complex the data sets have become and how long each data point takes to create, which is often like 15 to 25 hours. And so the talent has essentially gone from, generalists, crowdsource, which is basically anyone can kind of do these labelings to improve the models, to now folks that are better than the models, which of course is quite a high bar. So we're often looking for talent that, are PhDs, professors, very experienced folks in the industry. We have lots of lawyers, doctors, finance experts that are working across a lot of our projects.
I see.
Yeah, just to add to that, it's very much dependent on the use case. Just to give you a comparison, when we worked on launching first LLM with Google Translate in 2016, or improving search, improving ads, you just needed, as Ali said, generally that knows how to translate and can evaluate translation. But if you're going to specific domain, let's say for General Motors, how to design a car or design car design task, or when I was VP of AI at Cisco, how do you configure a router? You need a subject matter expert with a lot of expertise, and the task is way more complex. That's why, in my opinion, the use case drives the complexity, not necessarily whether it's RL or other techniques. That's to me what drives complexity of human collected data in evaluation.
Yeah, maybe we can talk about market size a little bit too. So, a Scale AI study that came out yesterday said there's 200,000 folks now that do data labeling in the US in some way, shape, or form. And most of these people are doing it part-time as kind of a supplement to their normal job. What types, I guess I'm wondering, what do you guys have any stats on market size, how much, money people can make, that kind of, do you have any information on that end?
Yeah, I think that sounds right. I think there's a lot of people that do this type of work now, and it's growing quite fast. I the way that we kind of think about it is this market will continue to grow, and I think the growth is actually going to accelerate because of these real world RL environments that need to be created by essentially every domain expert. So the estimate that I kind of use is I think the spend in this market is roughly 10 to 15 billion a year right now across all labs and enterprises. And I think in the next couple of years, this will surpass 100 billion a year. And part of it will be the labs continuing to spend and grow, but I think the perhaps a larger part could be the Fortune 1000 broadly spending on contextual evals to build agents. So the spend per company in the Fortune 1000 will be a lot less than the labs, but obviously there's a lot more of them. And I think that this upcoming year, these enterprises will kind of realize that the way that you implement agents in production at a large scale is to basically run lots of evals. And so it's going to become a very important part of the product development life cycles, where I think eventually these enterprises may spend large portions of their product budgets on evals, just like they do on engineering talents.
Okay, yeah, let's talk about enterprises. Barak, so you're coming from a large enterprise. Um, Give us some insight into where enterprises are in this readiness to use RL gyms and what's going to be coming in the next year or so.
Yeah, so my assessment is that most enterprises are still in the phase of getting value from prompt engineering, RAG, and kind of off-the-shelf tools, right? Now, again, it also depends on the use case that they are focused on, right? Or use cases. Only a minority, in my opinion, right now, truly ready for even serious fine-tuning, because fine-tuning, as I mentioned, it depends on the use cases, right? Fine-tuning makes sense when you already have clean labeled domain data and stable use cases. Now, it's easier said than done. Clean label domain data is in multiple sources. They need to be, centralized, clean, be ready, etc. You need to have instrumentation evaluation framework, actually tooling and framework. And I wanted to double down on what Ali said. I think the evaluation part is the most underappreciated aspect, how critical it is, because I'm constantly hearing people like, oh, we built something and it's great. And I'm like, how you evaluate it? Well, we asked a couple of people to evaluate the results. I'm like, that's not really, serious production grade evaluation. You will really need to be able to measure well. And finally, you need maybe small, but you need top tier internal AI teams that understand both how to fine tune or post train the model and the business process. Without those right now, fine tuning would be to some extent expensive distraction, because you will not get the value, because they need to know what you're doing.
So, well, yeah, so what does this look like over the next year? Like, so you were saying very few enterprises do this now. Like, do you think, what percent do you think will be doing it in the next year?
I think it will increase, but I think I would look at that as like, what is the focus of the enterprise or the group or the division? Because I generally, on a super high level, look at two simplified division of, there is a use case that are core to the business, and there are use cases that, let's call them corporate functions. Corporate functions on a super high level, unless it's a fintech company, it's finance, legal, HR. I believe you can really get by with, using off-the-shelf solutions with some kind of customization. If you're going to a core functionality, core for different companies different. For, physical AI companies like GM is designing cars, or designing planes, or designing, fridges. For, entertainment company is creating auto AI created movie or script or whatever, right? And for other companies could be something else. For each core function, probably the accuracy and ability to fully automate and act on it, it's way higher requirements for accuracy, and it's way higher domain specificity. And when they're ready in terms of ingredients, right, the data, I like the kitchen analogies. You really need to create a good meal in AI space. You need the infrastructure, which is like the kitchen equipment, infrastructure and models. You need ingredients like data, and you need staff, talent, right? So you need all three if you want to create a gourmet meal, which is like a use case that AI solutions that addresses core of the core use cases, those are way more complex and requires way more combination of those three things: models and techniques, good data, and good talent.
And to your other point, yeah, to your earlier point on getting the required talent needed to do this, do you see enterprises actually making moves to put together teams that are able to really execute on this?
Yeah, I think it's a mix. Some are more advanced than others. It's not that easy, right? It's like it depends on the use cases as well, because like there is a general, there's very few people that understand the space well. Now, if you're going to more specific or more frontier or novel areas like physical AI, which is very new, even the models are still not fully there. It's an even narrower sliver of talent. So I think it comes to the what's important, what's the like to what extent enterprise understand its core and the AI solution is core to their, to their business model, to their margin or whatever, and their ability to hire, motivate, and retain this talent.
Can you think of any examples of enterprises now that have currently been able to make any models for their core, like what you're calling their core ability?
Using off the shelf or using custom?
Using custom.
Custom, I don't think there is, again, I cannot think of an example. I think it's early. Obviously, a lot of companies experimenting with off the shelf. And just to be clear, in some areas, you don't need custom models for your core functions, right? If, let's say, you're in legal, you probably can use off the shelf. It highly depends on the nature of the core use cases for that enterprise.
Gotcha.
Yeah, and I think just one quick point to add there. I think in most cases, even when the enterprises start doing lots of contextual evals for their core and other use cases, a lot of times they actually, in my view, they won't be creating any models from scratch, and in some cases they won't even be fine-tuning any off-the-shelf models. They'll simply run a lot of evaluations on exactly the functions that any off-the-shelf model needs to be good at, and they'll make tweaks to prompts based on those evals. They'll make tweaks to the software layer. And I think those tweaks are as important, and I think lower hanging fruits with higher impact in a lot of cases relative to fine tuning. I think there's what we've seen with some of the customers that we talk to is that the evals always needs to result in fine tuning, and if an enterprise is not thinking about fine tuning, they don't think about evals. And I think those are just those things are not coupled together in every case. And even in our case, like if we're improving our AI recruiter agent Zara, we run what's called stability evals to basically track how she's doing in terms of lags in the video, latency, and so forth. And a lot of times changes that we make based on those evals are like, we change a fallback model, we change like a front end interface, and we don't always fine tune something. So I think that's an important distinction.
Okay, yeah, thanks. That's super interesting. Do you think most of the time people need to fine tune, or is it mostly you just need to just alter your prompt or do something that's much easier?
I think most of the time, because of how much these foundational models are improving and how much the labs are spending on fine tuning on their end, you actually don't need to do that for a long time. Of course, if your use case is very, very niche, you probably will benefit from some fine tuning. But doing lots of evals and understanding exactly the functions your model needs to be good at, and then changing prompts and kind of tools that are being used and the interface on the front end and so forth will probably have more impact for now.
Oh, interesting. Okay. Great. So I want to talk about RL gym vendor evaluation. So maybe for Rohit and Ali. What's the best way to do this, and what dimensions matter the most and are moving the needle in terms of model performance?
Yeah, I mean, I think thinking about like how it is used like today, right? Like the way that right now, most of the focus is still on training LLMs, and obviously labs are working on many other specialized models, but like focus like where the money is being spent, right? And if you look at how they work in these environments, it is through tool use, right? Like so you get a description of an API tool or something like that, and you are a language model and you're trying to call these tools. You're not actually like necessarily, going and operating in a physical environment, not just yet, because these tool use doesn't make it very easy to do that, right? Like it's a very high latency sort of thing. So that already restricts dramatically what kind of environments can these models operate in, because they have to operate through these APIs and tools. And so I think that's one criteria. It's like, can we plug it in to the thing in the first place, right? Like, does it work? And 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 then there's like how general is it, right? So you can think of as we were talking about earlier, right? Like use cases for RLs. There's maybe like two dimensions of those use cases. One is building these general models, and then the other is building specialized models that do certain tasks. So that's sort of like one dimension of on which general versus specialized, and the other dimension is who is doing it, right? Like the labs versus enterprises and companies, and the use case for most of the RL right now still sits in labs, but it could be general or it could be specialized if for example, Google is using RL for better chip design and stuff, and that's not unlikely that that's going into like a Gemini model, right? Like that's a separate effort there. So I think you can have these sort of like RL environments that are specific, and that those are useful for specific purposes, but they're not necessarily very useful for like general model training. That is going to be a consumer grade, like outside looking model. So that's certainly one criteria where the tasks have to be like useful enough that you think it will generally enhance model capabilities in the consumer space. And then obviously the questions of fidelity. Is it rich enough, and does it have high fidelity with the real world, right? You don't want models learning the wrong thing because the RL environment was sort of like, not very well specified and so on and so forth. And then you want to, make sure that there's enough variety in the sort of tasks there is, so that you don't sort of just like learn into like some finite pattern. So those are like sort of all general sort of standard concerns. And then maybe from a technical standpoint, like you also don't want environments that have like super sparse rewards. Like this is like LLMs are super compute intensive. Like we're not learning a game of Pong with like a 4-layer like network. These are like really large networks. If the rewards are massively sparse, this is going to be an issue. So you do want some somewhat like dense rewards so that you're able to actually train it reasonably. So yeah, I would say like those are maybe the top considerations.
Can you talk about reward hacking a little bit more? Like how big of an issue is it with RL gyms?
Yeah, I mean, I think so. If you think about reward hacking, like one sort of perspective is that reward hacking is ultimately like an issue of under specified environment, right? Like the real world, when you try to capture the real world, and sort of the model found a way to short circuit and get to something because obviously it wasn't like as specified. Now, the real world is so rich that there's no possible way of really specifying it completely, right? Like I'm sure there's some sort of a theorem that exists that wouldn't be possible to do in a computer simulation. So then you're like, okay, like we know this is going to be a constraint, and how do we sort of work around it? Right. And then there are many papers and like techniques that people are working on how to handle that. And some are really simple. Right? You show the model common hacks and you sort of tell it not to do it, and then it sort of learns not to do it. Or you can, there is a big sort of like line of research around like process observation, where you observe the process and you not just the final answer, and you sort of decide like what the reward is going to be. And so there are like these sort of research areas that are like gaining traction and becoming more popular to sort of address the and obviously the obvious answer, which is like keep specifying the environment more.
And you were also talking about plugging the RL environments and RL gyms into the training pipeline. So how hard is that actually? Like how much work is that? Or is it something that's easy to do or hard?
Yeah, I mean, I think like the take is that in general, right? Like the training process is a challenging process. Like it's not exactly an easy process. But if you think about what RL is if you have your reward function and then your update function, you can and if you set the advantage function to 0 or 1, that becomes sort of like SFT is a special case of that in a way. So I think from a technical standpoint, this is not like a massively challenging like thing. I think the challenge really is more in like, how does this work to affect the rest of your model training? How does it work with your data mix? Which environment is actually going to help? You have a finite amount of compute, so it's an optimization problem rather than like, hey, is this hard to get it working? It's not really hard to get it working. It's hard to figure out whether you should get this working for how long, how much compute to spend on this versus something else versus something.
Yeah, I would just add an enterprise perspective of trying, having a cutting edge team, trying to do custom training. Another challenge is that I think Rohit talks from a frontier model development perspective. But one of the challenges that in today's infrastructure of frontier model providers, they don't provide you a lot of access to customize the model because, to Rohit's point, I mean, it basically could affect the model. You don't want to have semi-random people start messing around with your model. So there is some basic fine-tuning or maybe basic or intermediate fine-tunings that all platforms like Google Cloud and AWS and the AI Foundry from Microsoft providing. But to go deeper into the model, the tooling doesn't exist, or it exists in a very limited fashion to, let's call it, whales, like very big clients with sophisticated AI teams and ability to spend a lot of money, right? So it's both technical complexities that might be relatively, let's call it, intermediate complexity for top-tier teams like Meta or Meta Superintelligence or Google, but there's also access component. Like, to what extent frontier model developers will allow you access to do it, right?
Yeah, and I would say like this question becomes a very different question when you start thinking about like open source models and people trying to fine tune them from RL from an enterprise standpoint. Like, I think what Barak was saying earlier, there are many stages before the world gets to that. Like, there is the stage of these companies first need to figure out and get into the habit of building good evals, right? And then once they have the evals, they'll be able to very effectively use the existing models and prompt engineer to effect. That's when they'll be like, okay, maybe we're not happy with it now. Maybe we start fine tuning because the eval is sort of telling them the North Star. Then they start getting into fine tuning, and then they realize now we need the RL gyms, right? Like, so this progression will take time. And the necessary sort of condition of that is like we get to a place where everyone has a good idea of how to evaluate before they start to realize, okay, well, I need RL because now I have a way of moving the ball forward, and I trust that I am actually moving the ball.
Okay, maybe next panel we'll talk about how to make a good evaluation then.
Another topic, a great topic, I think, at some point outside of this discussion is fascinating topic about frontier models, open source versus not open source. It's generally a very complex topic. Dave Zilberman from Norwest, we had a fascinating discussion about that. But that's a fascinating topic. It's non-trivial right now. Where do you bet on your frontier model, open source versus not?
Very interesting. Okay, for the next panel then.
Yes.
So question for Ali and maybe Rohit. Do you see RL environment creation being quickly commoditized over time? Is that going to happen?
I think until we can model the world itself, they won't be commoditized. And of course that's we can infinitely strive towards modeling the world itself, and I think that's sort of what we're doing with these general intelligent models. But we have it's an infinite journey towards that, and I think we won't be able to actually reach that, and therefore each domain that we need to improve models on will require expert domain data that will not be commoditized. And then of course there's also physical intelligence that requires even more dimensions, even more data, where the journey of physical intelligence will start with kind of similar how LLMs did with like generalists creating data, and then it will ultimately get to experts doing things in the physical world to train these physically intelligent models. So that'll take even longer to get commoditized, and I don't think it ever will.
Yeah. I mean, I think that is sort of I don't think like people fully appreciate how much RL we're going to need in the future. I think there may be, no matter what the future scenario is of where AI goes and bubble or not or whatever it is, we're going to continue to want to use AI in different scenarios. And the only way to make it good at different things is to be able to build an environment for that particular task or for that particular setting. and the world is infinitely rich. So like there is just like an explosion of things or places where people are going to try to apply this, build models to solve those particular problems. And they're going to need to build an RL environment for that before they can do any of that. And so I think there's like this is almost sort of something that is I feel like a little bit underappreciated, and people aren't paying enough attention because like only the labs are working on it right now. But in a few years, I can imagine that like everyone's just going to be going around building RL environments. That's the only way we know to actually have these models work on anything real and actually extract economic value from them.
Yeah, that's interesting. So, Ali, you're talking a little bit about the physical intelligence component. Can you talk about that a little more? Because right now our models are really just mostly text or image based or on the computer. So, what does that look like?
Yeah, so we
And why do we
you know,
need it?
yeah, so I think the way to think about physical intelligence versus LLMs is we're bound with this sort of this subset, which is a laptop, right? A laptop is certainly not the entire world, and LLMs can just act in this hardware, which is the laptop. And so the actions that they can do, which of course we're building lots of environments for them to actually be able to do things, such as file taxes, as an example that we were discussing earlier, is very, very limited compared to the physical world itself. So the next step is having agents actually act in the physical world and move atoms and not only bits. And so I think right now the phase that we're at for physical intelligence is creating basically the pre-training data set, the sort of internet equivalent data set that does not exist. And that will require lots of data from generalists that are essentially kind of doing things in the real world, recording themselves do those things, and then we annotate those actions for what's called VLA models. And of course, there's other architectures, but this is sort of one of the main architectures that we're going after. And then this will take probably a couple of years for the physically intelligent models to sort of have its pre-training data set ready. And then afterwards, we're going to kind of converge towards this expert level data and go through a similar trajectory as LLMs. And we kind of look at it as the pillars of the way you train these models are kind of similar. You need to source and vet the talent that needs to train them. You need some sort of data platform, which in this case can be, Meta Ray-Ban glasses and other types to actually record the data. And then you need a pipeline to manage the performance of that data and the velocity of that data. So we're kind of, what we're doing at Micro One is essentially kind of converting the data engine that we have and translating it to physical intelligence.
Yeah, just to add to that, working on that very recently, it's definitely new exciting frontier for, first of all, they're relevant for LLMs as well. Those physical models will leverage LLM a lot because it's definitely next frontier as LLMs meeting the physical world. And the reason I believe Ali mentioned data, but I think we probably need to start from the model. So I think one thing, the good news is that there's recent LLM advances across text understanding. For example, let's say, I don't know, if you want to design a robot that, can load a dishwasher as an example, operate a dishwasher. We already have ton of text training about ability to understand dishwasher manual. Then you have multimodal understanding. Let's say ability to learn from video on how to operate a dishwasher, or ability to read a cat file. I mean, some frontier models like Gemini are really good at reading a cat drawing to learn how, let's say, grab a part, right? And you also have LLMs becoming very good at reasoning to understand complex relationship also. So that will likely make it possible. The challenge is that, to Ali's point, it's a very novel field that requires bring all those together because no model yet is doing that. This complex understanding of the relationship between all those is not there yet. And that will require data, as he mentioned, but also require, as he said, specific and rare to find AI talent, not only on the data generation side, but even on the training side. So it's definitely very exciting. There is way more cases in physical world than in digital world that could be, and it's a very new, exciting frontier, but it's in a relatively early phase, but it's moving fast.
Yeah, and Rohit, you mentioned there being the need for a ton more RL in the future. Are there any favorite examples that you have of things that you think will be need to be trained in RL gyms in the future?
I don't know about favorite, but one of the things that I think a personal annoyance of mine is, navigating the digital world where you have, it's 2025 and all of my apps have menus and buttons and things, right? Like, and I think you can imagine like this is a relatively easier RL problem to solve. So this is more of an adoption issue than a technical problem. I don't think so where why can't I converse with my things and then it can validate or confirm later. So I think there are already like sort of like from a technical standpoint already solved things where you can easily build an environment, an RL environment, and my bank can build an RL environment on their app and like have me just basically an agent interact and do it, or my travel partner or whatever it is. So those are things where you're sort of like maybe finding yourself spending time and you're wondering, why am I spending time on these things? Where like,
I
so
understand. Yeah.
yeah, so I would say those are more the things that pop to mind. Not very exciting and technically not very challenging, but I think we still need to go and actually apply these and into all these places and do it.
To your point, like, do you think enterprises or companies will allow AI companies to train on their environments, or will we still need RL gym companies to kind of clone these apps to allow training?
I'm not even sure that the best solution is to have big models have the ability to do these things. Maybe general navigation abilities is okay, but I think actually the right solution here might be that the enterprise itself trains a version that on its own environment that works really, really well for interfacing with them. And so when I'm interfacing with that particular sort of business, that their model has been trained on their environment and actually can interface with internal sort of APIs really, really well. And I just end up seeing, that. And I think that's maybe the end state of this, because I can't imagine that with the possibility of like how many things are out there, I can't imagine that there will be one model or one set of models or any model by any lab that can just generally be coded. But you do want to get some ways there. So you want good zero-shot capabilities to begin with, for these enterprises to then take it and further fine-tune, right? Like, so you don't want to start from scratch. And that's where you need RL gyms, because that's where you need gyms to be able to make sure that the models come out when they're released, they have certain base level of zero-shot ability to do all of these things. And then people can further fine-tune.
And Barak, do you think enterprises will be game to do that, to train on their own sites, I guess? Because I think right now, what I see is that a lot of enterprises are trying to block AI agents.
Yeah, so look, I think eventually yes, but not everywhere and not all at once. As I mentioned, you need to have all three things. You need to have the infrastructure. That is kind of easier, because if you choose a model, you will definitely not start from scratch. You'll not develop model from scratch. But you also need ingredients in a good shape, right? Otherwise, the problem is that the ingredients will come in different flavors. It will come late and will come with different quality in terms of data. And you need, kitchen stuff. You need talent, right? So I expect that leading enterprise that kind of understand it and focus on their core use cases will start building those small cross-functional AI product teams that will own both defining the use case as well, because it starts with that, then kind of evaluation, data pipelines, and fine-tuning post-training for a handful of mission-critical journeys. And as I said, own means doesn't necessarily mean you develop everything yourself, but you basically need to create that coherent picture of like, okay, I have a combination of buy, build, or partner. I will use third-party tooling. I will use something internally, etc. And all this is very non-trivial work. So I think it will take time to go there.
Yeah, I think just one quick point to add. I think there's almost no case where you can just take enterprise data off the shelf, like from the database, and then just like train on it. I think, if you're creating some SFT data set and you want to train in sort of an unsupervised manner, and maybe you're not building any sort of LLM and you're not fine tuning, but you're maybe building a model that's niche to your use case. Even in those cases, you need to sort of make an equivalent to an RL gym in a way. Like, you need to structure that data. You need to at the very least kind of categorize it and clean it up. And so I think, the way to think about enterprise data is that it's not really like mutually exclusive to RL gyms. Like, you sort of need enterprise data to build RL gyms, and it's it's not always a necessary component, but if you are using enterprise data, then it could be a very important component. And I think just real quick, back to your question, Anna, in terms of like favorite RL environments, I think I don't have a favorite RL environment, but I think my favorite thing generally about RL environments is the fact that experts and just like humans in general are able to do tasks that they already do that they're really good at and get paid for those tasks, oftentimes get paid more than what they make in their day jobs to train models that'll help them in the future do those tasks. And I think that's like just like a beautiful thing to think about.
It's fun. All right, so we have about 10 minutes left. So I wanted to open it up for audience questions.
Thanks, Anna. Dave Zillman here with Norwest. I've just been monitoring the Q&A. So the first question that came in was about browser gyms. Curious if the panels have a perspective on browser gyms.
I assume the question is about AI browser gyms, if I had to guess.
Yes.
Yes. So
Yes.
this type, I'm talking mostly about playing with those, and I feel, I tried both Comet from Perplexity and Atlas. I think it might actually require some kind of additional, maybe grounding or additional RL learning, because one thing I discovered, and we discovered at an early stage of LLMs as well, I was asking to do a very simple task of downloading a bunch of files from a page, right? And as I did it, it took 10 minutes, but I didn't need to do much. But when I observed what's actually happening, it reminded me early days of LLMs that you're basically interacting with not very competent but very apologetic intern. They're like, oh, let me try this and let me try that and let me take a bunch of screenshots, etc. So all this, when you're taking a lot of action, and you want to basically make sure it's done just right, it requires a lot of trial and error and a lot of grounding. So I think that will require way more work, because it basically, to me, back to the point of agentic or action-based. So yes, I believe if you want to go deeper into AI browsers that will take tasks like that, I would consider pretty core buying something, right? Finding something and buying something that will require a lot of chains and a lot of kind of agents connected together. I believe it will require more of it. Just Ali mentioned exponential nature of amplifying a mistake. Just super quick example from 10 years ago, we effectively developed first LLM-based agent in Google Translate, which was voice recognition and translation. And we discovered exactly what Ali said. That was 2 agents, right? One small mistakes in voice recognition created complete crappy translation on the outcome. So when you're doing things like on AI agents that they expect to do something autonomously, it requires way more model fine-tuning and potentially RL training. So I do believe it might be very relevant as a use case.
Yeah, I mean, one other thing to add about browser gyms is it's not clear that in the end state, how much of that usage is good to do with AI, in the sense that like browsers are for human interaction with inherently sort of digital sort of databases and things like that, and make changes in there. But if you have enough of a protocol developed, right, like over time, as I think it's going to happen, for AIs to directly interact through APIs or whatever means with and do all of these things, the sort of like the surface though of what you can't do there and therefore need to do in a browser is going to sort of shrink, right? So I think that sort of poses another question, because the main thing about browser is you can do everything a human can do and there's no restriction, right? Like, but also possibly people might end up starting to put restrictions on what AIs can do in browsers down the line and find ways of figuring out. So I think there's like a sort of a tricky space with browser gym. It's not clear that in the end state, like that this will even be a thing or not. And there are definitely challenges to that. Maybe you're on mute.
Thank you. Good observation. Another question that came in was, would the model providers themselves want to develop the expertise and the specialization within certain environments versus letting a wide variety of environments flourish? Or would it be the models themselves that develop this expertise?
Yeah, I think Rohit and I are actually talking about this last week, of like this idea of improving models in very specific domains versus taking the approach of trying to do so generally still. I think the the sort of not confident conclusion that I've come to for now is that general improvements seem to be coming from just domain improvements in all domains, which obviously is a really hard thing to do. But I think there's of course there are domains that have kind of emergent capabilities, which is coding and others that labs kind of emphasize because of their emergent kind of generalized capabilities. But I think because of the fact that domain improvements in basically in all domains is what I believe will result in kind of general intelligence. This naturally will have to result in model companies kind of focusing a bit more on certain domains versus all domains.
Yeah, just to add to that, I just had deep discussions with all model providers. And it's obviously, I think, rightfully, they're prioritizing the domains, right? Because they're talking about enormous scale, right? You're talking about, and obviously hyperscalers have a more diversified business model. They also look at that more holistically, like the scale could come not only how much you'll use a model, but could be how much data and compute you will use. But at the end of the day, they'll prioritize use cases, how generalizable the use case is. We also need to understand it's a non-trivial engineering challenge to maintain many models, right, for frontier models. So we experienced that at Google Translate many years ago, and people will come to us and say, can you please customize translation from English to Chinese to Singapore, as an example, right? Because they have their own variation of Chinese, and it's always a challenge. So I think it's a non-trivial question, but I agree with Ali's sentiment. There'll be domains that will be generalized enough, big enough for frontier models to potentially invest, but there'll be domains that will probably prefer to either partner or let people provide them more access if needed to customize.
Yeah, I mean, I don't think also it's realistic. Like as I was saying earlier, with how rich the world is and how many use cases for AI there are going to be, it's not realistic for anyone, let alone labs, to think that like we can do everything. So you sort of prioritize the ones that are most widely applicable. But realistically speaking, also like everyone else that has their own use cases is going to work on that, and that's a good thing. I think that will move forward, everything over time.
Great. So maybe one or two more questions. So another question came up, and this is both for maybe Rohit and Ali, your perspective as both a vendor and a consumer. Is it preferable to have a vendor that already has established environments in a certain domain, or an ability to build a bespoke, unique environment? What's the preferred route?
Rohit, we'd love to hear this from you, and here to your request.
I would say, like, I think you're going to get a different answer depending on who you ask on the team. So I think there is potentially both that is valuable, but personally my use cases have been more on the latter, where it's like, hey, I have something in mind and I need an environment for that sort of helps me achieve that, right? Like and the approach that you can take, like, so if you see recently, like Since was one of the things we released, open sourced it. One of the approaches you can take is you build like sort of the technical scaffolding of the environment, right? Like sort of you write the code where like the simulation, whatever, and then it needs to be populated with sort of real world data. And that's where you sort of maybe call a vendor and be like, hey, like we're going to give you the tools that you need to now make this environment come to life, so to say. But the code is sort of written, right? Or you just go and you say like, hey, this is sort of what I want. Like, just make the whole environment, write the code, populate it with data, situation, or like methods to populate it with data, sort of like the meta of the data itself. So I think that's been sort of like more my personal use case. But I think if you ask somebody else in the team, they might give a completely different answer for that.
Yeah, I think the way we look at it is like ultimately we want to get to a point where we have the full environments built out, and what that means is essentially lots of data with a really good reward model that a lab can essentially fully trust and kind of connect to our API to improve their model capabilities in that domain through our reward model. I think the truth is that we're kind of far from that. Like basically what we do currently and the way we kind of work with some of our customers is we build the initial base of the environment, similar to what Rohit was saying. We kind of built the initial code base, the state space, action space. We have some initial data points. that kind of results in a base reward model. And then we go and work with the lab to kind of further enhance that and go in a direction that they actually want based on the use case they're thinking about. So I think that that's sort of it's more on the bespoke slash custom side of things currently, but I think long term it'll sort of converge to, ultimately we'll have tens and eventually hundreds of reward models that are fully built out that we're continuously feeding data into, that labs kind of depend on for model capability improvements.
Okay, great. Well, appreciate thanks everyone for joining us today, and special thanks to our three panelists, Ali, Barak, and Rohit. And of course, Anna, wonderful job today. Hope everyone enjoyed it, and we look forward to seeing you next time.